right? Because rat and R, two different number groups, I and irrational, two number groups, so keep track of those. All right, so, let's see. The number four, we did this before. Let's, while we're doing this, instead of just doing numbers like, let's start easy. And then we're gonna go to square roots and stuff like that. But where would 3 go? If I was to place it in that Venn diagram, where would it go? Evelyn?
Natural.
Yep, it would go right in here. Because if I know it's natural, I also now know it's whole and integer and rational and real. Okay, so you always think of, you ask yourself, first of all, is it rational or irrational? And if it's irrational, you're done. But if it's rational, you have to think, what's the most specific way I can call this number? So let's go with the square root of 21. What is that number? Can you remember using estimating square roots, where that is approximately? Who can recall that process for me? Do you remember? Like to estimate, you know what I'm asking you? Like estimate it to the 10th place. If I said, what is that value? How did we do those? Come on, you were really good at them. Olivia?
You took the 2 square roots it was closest to.
So which 2 would that be between?
Square root of 16 and 25.
Okay, and that's 4, and that's 5. So now what?
You would say which one it was closest to and then estimate the first one.
So this is 5 away and this is 4 away, so it's just a little closer to that direction. So what would our guess be?
4.6.
4.6 is a good guess. Guys remember that? Yeah, you're good at that. So if I'm looking at this, this is about 4.6, but remember I'm saying it's about. It's not a perfect square, is it? Where would it go on the chart?
In the rational. On the rational.
Rational? What makes you choose rational?
Because it has parts and decimal.
It does have parts, so good. It's not any of these, but the question is it rational or irrational? Why would you choose rational? Did you forget about the irrational?
Yeah.
What do you think? What if what I wrote so far gives us a clue?
It's about.
Mm-hmm. And if it's about, I probably rounded it. So perfect squares that are, said that wrong. Square roots that are not perfect squares are most likely irrational. Good job. So think of that in general. If you have a square root and it's a perfect square, it's going to be in where the 3 is. Because that would be like the square root of 9, right? But if it's not a perfect square, it would go here. So we would say this one is irrational and real. So what these are called, yeah, these are number groups, but if I'm classifying this, it might say, write all the subsets of the number groups that the number belongs to. And that's what we're doing. Let's do a few more of these. How about Angela, what do you think about this one? -3/5.
Rational.
Okay, good. It's definitely real. Out of these two, it is rational because it's a fraction. and that's part of the definition. It's got parts to it, so it wouldn't be anything in the circles, it would just be right here. And you know what, I think some of you may have thought, is since it's negative, wouldn't it be an integer? That's not what makes a number an integer, it's gotta be no parts as well. Okay, so if we had like -4, that would go here. All right, give me a number that would go here. Caleb, did you hand up?
Yep.
What? 0. Is that the only number that can go there?
Yeah.
Cause any other number that's above 0, that's, doesn't have parts to it, would also be in there. There's some more examples for you. Okay, I'm gonna go through and I'm gonna give each one of you a number. You use that. Let's see how we go, okay? Preston, 17. Tell me all the numbers that it belongs to, all the number groups.
Belongs to natural, whole, integers, rational, and real.
Good, that is right.
You.
Caleb, -10.
Integer, rational, and real.
Yeah. Derek, 0. It went away. 0. Oh,
Integers. Rational. Real.
good job. There we go. Rashawn, -1/4.
It goes in rational and real.
Yep. Angela, -2.6.
Rational, real.
Mm-hmm. Paxson, -5.5.
Rational. Integer.
Integer has, does an integer have parts?
No, yeah.
It is one of those. Remember, definition of integer is a whole number or its opposite.
Oh, real.
Alright, good. I'm giving you guys those on purpose, just cause it's got a negative sign doesn't mean it's an integer, right? Lisa, how about, pi?
Irrational. And real.
Mm-hmm. Always real, right? Evelyn, 1.6 repeating.
Irrational and real.
Why do you choose irrational?
Cause it's repeating. Oh
Look
wait,
at,
rational,
there you go, that's part of the definition, right?
yeah,
And,
real.
good. Olivia, how about negative 1.454?
Rational.
Good. It looks like a little start of a repeat, but it isn't. It's a terminating, well, even if it was repeating, but it's rational. Good. Loose, how about 2/3?
Rational.
Good job. Chloe, square root of 25.
Rational, real. And,
Because, what is that equal to?
5,
So you're really classifying the number 5.
so, whole,
Whole.
and, neutral.
Natural.
Natural.
Yes.
Natural.
Good. And Lily, how about, negative 0.75? What did you say?
Rational
Yes?
and real.
Good job, everybody. How many of you actually looked at the Venn diagram to do that? I think it's helpful. All right, one last thing I'm doing here. So then now we know all of these different forms. What if it said order the real numbers? Why is it doing that? And we have like -2, square root of 17, 3.1, and 0. Let's go from least to greatest. What do you think? How would you do that? Caleb?
Just like order of this is,
Yeah, I mean, how you gonna do that?
look at the lowest one.
Huh?
Look at the lowest one. -2.
Yeah, so we know the negative come first, that's good. Are you gonna keep going?
0.
0 would come next.
And then 3.1.
Oh.
Right here, 0. And square root 17.
How do you know the square root of 17 is there?
Because, you multiply 3.1, or just 3 by each other, will only be like 9, so.
Okay, or I'm thinking, well, that's close to square root of 16, so it's 4 point something, right?
Yes, that's it.
Okay.